Hello Advanced Algebra students, and welcome back to another video lesson for Advanced Algebra as we continue to look at trigonometry. Today we are going to focus on two special right triangles, a 45-45-90 triangle and a 30-60-90 triangle. These two triangles have some very unique properties that allow us to, in a sense, be more efficient with how we find side lengths. So let's take a look first at the 45-45-90 degree triangle. This is formed from a square because my two legs are exactly the same. This is also known as an isosceles triangle, but more specifically, we have to have 45, 45, and 90. When we have that, the two legs are going to have a length of x, and then the hypotenuse will have the length of x times the square root of 2. This comes from the Pythagorean theorem, ironically, in that if we did leg, a squared plus b squared equals c squared, we have 2x squareds equal to the hypotenuse, and then we're dividing by 2. And there's a long process to go through this. But I want you to focus on this diagram up here. Anytime we have a 45-45-90, the legs have to be the same. So we label them x, and whatever we find for that x, we can put in front of the square root of 2 for our hypotenuse. We are going to leave our answers in this section with the root. We're not going to change them to a decimal and multiply them out. We're going to leave that root, square root 2, and other things, because those are the exact answers that we want. All right, let's take a look at an example. See if we can't find x and y in this triangle below. I've left this up here on the right for a visual. What do you think the value of x is? Well, notice this is definitely a 45-45-90 triangle. 45-45, so our legs have to be exactly the same, or x would have to be 5. So x is going to be 5. Therefore, if x is 5, what does that make y? Well, hopefully you can see, going back to this diagram, the hypotenuse is whatever number the leg is times the square root of 2, or 5 times the square root of 2. And so notice we don't have to use our trig functions to get this. These are a special right triangle, 45-45-90, that has some more efficient methods, shortcuts, if you will. All right, here's another example. See if you can't first start out by maybe finding x or y. Again, this is a 45-45-90 triangle. That means x and y are actually going to have to both be the same. So whichever one we find, it's going to be the same answer. If we go back over here to this diagram, 4 times the square root of 2 is actually equal to x times the square root of 2. So if I divide by that square root of 2 to get x by itself, cancels out that square root of 2, it cancels out that square root of 2, and we're left with 4. X and y would have to be 4. Some of you will see that and notice that right away, the number in front of the square root of 2 is the leg, and that's fine. We'll use this a little bit later in tomorrow's lesson. So that's the 45-45-90. Now let's take a look at the second one called 30-60-90. This is formed from an equilateral triangle, right? Where if all of the sides have been the same, we drop this altitude. Now pay close attention to this diagram. The short leg, which is opposite 30, right? It's opposite 30. The short leg will always be labeled the x. That's our x. Then the longer leg will be x times the square root of 3, and the hypotenuse will be 2 times whatever x is. So this is the diagram you want to make sure that you probably have written down in your notes and something to go back to. Short leg is opposite 30, and that's the x. That's where we're going to try and start. Hypotenuse is 2x. Long leg is x times the square root of 3. Let's take a look at an example and see if we can figure this one out. Okay. In this diagram, see if we can't find x and y based upon 7 being placed over here. Start with x. What'd you find for x? Well, we have to remember that 7 is the short leg. This is our short leg because it's opposite 30. All right, so that's the x in this formula over here. The long leg, this is our long leg, means we're going to take whatever the short side is, 7, and put it in front of the square root of 3. So x is going to be 7 times the square root of 3. Can you find y? Well, y is 2 times the short leg. 2 times x, 2 times the short leg, 2 times 7 gives us 14. So our y value in this diagram will be 14. Let's try another one. What happens if they give us the hypotenuse? All right, can you find the value of x over here? Well, we know that the hypotenuse, right, that 20, the hypotenuse, has to equal 2 times my short side. My short side in this diagram is labeled x. And so if it's 2 times the short side, we've got to work backwards to figure out what that short side is. So 2x equals 20, meaning that short side x would have to equal 10. Or x in this case, x equals 10 for our short side. Then the long side, whatever we got for the short side, we're going to put in front of the square root of 3 and say 10 times the square root of 3. 10 times the square root of 3. One more example. See if you can't figure out. Last example. Can you figure out what x and y are in this diagram? This time, we've got to make sure again they gave us 30, 60, 90. This time they gave us the long leg, 6 square roots of 3. Okay, 6 square roots of 3. And if I go over here, 6 is in front of the square root of 3, meaning 6 must be the short leg, or x must equal 6. And if I use that to help me find the hypotenuse is 2 times that short leg, meaning y will equal 12. Okay, y will equal 12. Now, one of the other skills, I'm going to introduce it to you now in case it comes up on today's practice, but it is called rationalizing the denominator. And I will fix the layout in just a moment. Rationalizing the denominator. Mathematically speaking, we don't want to have a square root in the denominator. If we ever end up with a square root in the denominator, there's a process called rationalizing that will help us, in a sense, get rid of it. And so my question to you is the following. If I were to do the square root of 3 times the square root of 3, what would we get for an answer? Well, ironically, when you multiply square roots, as long as you're multiplying, you can put them both under the same one. 3 times 3, which gives me the square root of 9. But the square root of 9 really is 3. And again, plus or minus, but when we're talking about triangles and distance, we're only talking positive. Okay, so the square root of 3 times the square root of 3 through this whole process really turns into 3. All right, let's use that. What is the square root of 11 times the square root of 11? Hopefully, you recognize that that's the square root of 121 or 11. Last one. What is the square root of x times the square root of x? Again, if you put them underneath 1, you get square root of x squared, which really just means it is x. Okay, and this process helps us to rationalize a denominator. Rationalize. For example, let's just say we ended up with a problem that looked like 1 over the square root of 3. That's improper. We don't want to have that in the denominator, so we're going to multiply by the square root of 3 over 3. Why am I allowed to multiply by the square root of 3 over 3? Well, ironically, that's just the number 1. Square root of 3 over square root of 3, if you go to a calculator and you type it in accurately, you get 1. And so if I'm multiplying by 1, I'm not really changing the problem. Right? So on top, we get 1 square root of 3. Not going to combine those because 1 doesn't have a square root and 1 does. But on the bottom, square root of 3 times the square root of 3, as we already went through, is 3. And we get square root 3 over 3 when we rationalize it. Now, I'm going to have a more specific video going over more specific examples tomorrow. This is just a quick introduction in case you get any questions on today's quizzes that might ask you about this. Hope you took notes. If you have any questions, I hope that you do indeed reach out. Until next time, everyone, stay safe.